one I don't remember, stop me and I can choose another. Okay, so let's think of a substitution here. What do you think? It's okay if you're wrong.
But u represent 1 plus x to the third.
Of course, this is what I don't like. Yes, let's say u equals 1, this is not really good, I guess. 1 plus x to the third. But remember, only if du is easy to make. Plus or minus a constant, I don't care. That I can make it up very easily. So?
That would be 3x squared, right?
Careful. This is not, we're not talking about the derivative. We're not talking about the derivative, we're talking about the differential of u.
Three x squared dx.
Brilliant, indeed. It's all accounted for. The integral from u to -5 du. Because it's 1 over u to the 5th, I have to change it into u to -1. So then is u to -5 plus 1 over the exact same number plus a constant c, or -1 over 4 u to the 4th. But I have to go back now. For the indefinite integrals, you can always check. Differentiate this and see that you get 3x squared over this, guaranteed. Any questions before we choose another? Any questions? Okay. Okay, there is a text from me, a chat. Okay, no worries. Good. So can I choose now a definite integral? Do we need another like this, or an indefinite? Or can we move on to a definite with substitution? Do we need more with definite? With indefinite before we move on to definite? I don't know what to do.
I think you can move on to definite.
Okay, let's do a definite then. Okay, let's say 48. The integral from 0 to 1, x squared plus 1 to the 5th dx. The very first thing that we need to check is whether this function is continuous on 0, 1. That is the first step. Is this function defined and continuous on 0, 1? Otherwise, we cannot continue. If it's not, I will immediately write FTC, fundamental theorem of calculus, not applicable.
Yes, it is.
Perfect. It is, so we can continue. So let U be
X squared plus 1.
that's it. As long as du is easy to make up. Or even there, completely.
X dx.
2x dx, awesome. Do I have the x? Yes. Do I have the x? Yes. I don't have the 2, no problem. This is a piece of cake. Now I have the 2 as well. But I cannot multiply by 2 without dividing by 2. I can't change the problem. So now I move everything to u. Do not copy the limits of integration. So 2 and x and dx, 2 and x and dx, du. This is u to the 5th power. When x is the lower limit, 0, how much is u?
1.
Very good. When x is the upper limit, how much is u?
2.
Excellent. So now I do not go back. It's a definite integral. It's going to be a number. It doesn't depend on x or u. So it doesn't matter. I'm not going back. I'm not looking back. So this is 1/2 u to the 6th over 6 from 1 to 2. Remember the constant stays in front, waiting patiently. 2 to the 6th minus 1. I'm fine with this. If you want to keep it at that, that's fine too. If this is okay, you get 100%. If you want to continue, you can. It's not a big deal. But I don't want you to get entangled in arithmetic and waste time and get upset. The arithmetic is not important to me. You can calculate it with the calculator. You can put a number in there if you want.
Real quick, Professor, where did the 1/2 out in the front come from?
I cannot make a change without dividing by 2. This has to be 1.
Okay, I got it.
If I multiply by 2 and I don't divide by 2, I change the entire problem. I needed a 2 because of this. But I cannot just say, oh, let me multiply by 2, so what? No. If I multiply by 2, I have to divide by 2.
Okay, thank you.
Thank you.